an experimental investigation on high-strength concrete with Metakaolin and glass fiber. Project presented by R. Dinakaran, T. Gokulan, C. Sunil Kumar, S. Vinod Kumar. Guided by Ms. Tendral, Assistant Professor, ME Structural Engineering. Various contents present are abstract, objective, introduction, literature review, experimental program, result, conclusion, reference. Abstract. A study has been undertaken to investigate the effect of incorporating local metakaolin and glass fiber for the properties of high-strength concrete and designed for a constant water-binder ratio of 0.35, metakaolin mixtures with partial replacement of 1% for cement and constant for glass fiber, replacement of fine aggregate from 0.5, 1.5. Design target is M60. Objective. The main objective of the study is to achieve high-strength concrete by using metakaolin admixture and glass fiber. The study also includes the performance of the concrete by using metakaolin and glass fiber with respect to the compressive strength. Introduction. Metakaolin. Metakaolin is a dehydroxylated form of clay, which is the last form of obtained, from the clay. It has been obtained by heating the clay to the particular degree Celsius. Glass fiber. AR glass fiber is essential for GRC because of the resistance to high alkalinity levels on the cement. The fibers add strength and flexibility to the concrete, resulting in a strong yet lightweight and product. Literature review. We have referred nearly 4 to 5 literatures, in that we are representing the 4 literatures. First literature. Optimum usage of using metakaolin and corridors in high performance concrete. Presented by G.R. Vijay Shankar, Dr. D. Suchi. Second literature. An experimental investigation on glass fiber reinforced high performance concrete, represented by Vaishali G. Gorpade. Third literature. Recycling of waste glass as a partial replacement of fine aggregate in concrete. Fourth literature. Experimental investigation of partial replacement of sand with glass fiber, presented by T. Subramani A. Musaj. An experimental program. It was proposed to study the compressive strength and tensile strength of the specimen with different combinations. Material and mixed proportion. Fine aggregate was available, locally available reverse sand, and coarse aggregate for SP. Superblasters. Superblasters was tested on 0%, 1%, 1.5%. We used 1.5% and we got nearly 7 to 100 mm normal slump. Mix design for M60 grade. Cartridge set the M60 and type of cement used is OPC grade of 53. Specific gravity 3.15. Maximum size of aggregate 10 mm. Type of aggregate is crushed stone aggregate. Bulk specific density is 2.7. Type of sand natural river sand. Specific gravity 2.6. Reduction of water content. The total amount of water content is 221 liters. But on reduction of 30% has been achieved and total water content is 155 liters. Calculation of water content. Water cement ratio is 0.35 and the water content volume of coarse aggregate is 0.63 and volume of fine aggregate is 0.3. Mixed calculations. The total volume of concrete equal to 1 meter cube, volume of cement equal to 0.140 meter cube, volume of water equal to 0.155 meter cube, volume of chemical admixture equal to 0.0054 meter cube, volume of aggregate equal to 0.699 meter cube. Mixed ratio. Mixed ratio for cement, fine aggregate and coarse aggregate is 1 is to 1.6 is to 2.69. Water cement ratio is 0.35. Mixed proportion. Quantity of materials required for casting 1 cube. After adding wastage of 5%, cement 1.512, metakaolin 0.026, fine aggregate 2.502, glass fiber nil, and coarse aggregate is 4.389. Water content is 530 ml. Quantity of metal required for casting 1 cylinder after adding 5% of waste. Cement 2.38, metakaolin 0.041, fine aggregate 3.96, glass fiber nil, coarse aggregate 6.89, water content 830 ml. Quantity of metal required for casting 1 beam after adding a wastage of 5%. Cement 2.24, metakaolin 0.039, fine aggregate 3.74, glass fiber nil, coarse aggregate 6.50, water content 784 ml. Mixed proportions for 3 cubes, cylinder and beam. For cube, for cylinder, for beam. Glass fiber is varied as 0.5%, 1%, 1.5% and same for cylinder and beam. The various materials used are metakaolin, glass fiber and superplastic. Properties of materials. Metakaolin specific gravity is 2.57 and its a binding of concrete is reduced. 8 to 20% of cement pozzolanic react in 7 to 28 days. Increase the durability. Main strength is it increases the durability. AR glass fiber. Density 2.7 grams per centimeter cube. Its tensile strength is 1700 megapascal, percentage of elongation is 2.3. The various photos of mixing and casting have been presented in this slide. Mixing of concrete, casting of cube and cylinder, casting of testing of cube, cylinder and beam is said in this slide. The results: compressive strength for M60 concrete and compressive convention. For 28 days, we have achieved nearly 68.88 Newton per mm square. The graph for the compressive strength is mentioned in this slide. Compressive strength for partial replacement of mineral armature and tube at 28 days. In this, Metakaolin is kept as constant 1% and glass fiber is varied as 0.5, 1.5. The compressive strength, maximum compressive strength was achieved in 1% Metakaolin and 1% glass fiber. 70.44 was the maximum compressive strength. The graph for it is represented in this slide. The comparison of results for partial replacement of mineral admixture in cube is being represented as a bar chart in this slide. Split tensile strength. For convention. In this also, the Metakaolin is kept as 1% constant, glass fiber is varied as 0.5, 1.5%. We got the maximum compressed split tensile strength for the conventional concrete 6.22. Split tensile strength for M60 concrete. The graph has been represented in this slide. Split tensile strength for partial replacement of mineral admixture cylinder at 28 days. In this also, Metakaolin is kept as 1% constant and glass fiber is varied as 0.5, 1.5. The maximum strength has been achieved as 1% Metakaolin and 1.5% glass fiber. Flexural strength test, conventional concrete. It has been done for the beam and it is also Metakaolin is kept as constant, glass fiber is varied as 0.5, 1.5. Partial replacement of Metakaolin partial replacement of mineral admixture in beam. Conventional concrete is mentioned. Structural strength of M60 concrete after 28 days. We got the strength has been increased gradually after adding upon 1% Metakaolin and 1% glass, 1.5% glass fiber. So we conclude our project with this ratio. Results and conclusion. The final results are to achieve a high strength concrete after 28 days. Cube maximum compressive strength was 70.44 Newton per mm square. For cylinder 8.49 Newton per mm square. For beam 5.7 Newton per mm square. The conclusion. The study clearly indicates that 1% of replacement of Metakaolin by cement and 1% fine aggregate by glass fiber. Metakaolin and glass fiber is encouraging and the compressive strength is higher than the conventional concrete. This glass fiber gives more tensile strength when compared to others. Percentage of mineral to be increased as slump value will decrease. In this real world, spending amount for the construction is increasing day by day. But the rate of glass fiber is very high when compared to other materials. The various references used are IS 10262 2009, MS City, ML Gambhir, and reference. Thank you.